Okay, let's look at the exam 3B, problem number 1. Right, a boat is being pulled toward the dock. So let's say I'm gonna put a boat right here, and here is the dock right there, and the rope is being pulled by a winch located 9 feet above the dock. So it's gonna be up here. So that's gonna be 9 feet, right? Then rope is going like this, right? At the rate of 4 feet per second. So this is pulled in 4 feet per second, right? And how fast is the boat approaching the dock when it is 12 feet from the dock? So 12 feet is right here. So I'm going to just put the 12 feet, right? So we want to know how fast, right? So this is feet per second, right? So this is what we are looking for. All right. So we're gonna give variables for changing quantities. For example, the distance between the dock and the boat. So I'm gonna call that x right there, right? And the length of the rope. So it's the distance between the boat and the winch. I'm gonna call that r. All right. So by Pythagorean theorem, if I can spell this guy, Pythagorean theorem, right? So we have equation. We can say x squared plus 9 squared is equal to r squared. So x squared plus 9 squared is equal to r squared, right? And then look at the givens. So what are given? Right, so there are some given quantities. For example, at this point the x is 12, so you have x equals 12, right? Then since the rope is pulled in at the rate of 4 feet per second, so rate of change of the length of the rope with respect to time would be -4, right? Because the length of the rope is decreasing, right? And also we can figure out r using a Pythagorean theorem, right? So if you want r, you just have to take the square root of x squared plus 9 squared. So in this case, x is 12 squared plus 9 squared, right? 12 squared is 144, and 9 squared is 81. So 144 plus 81 is 225. So that's 15 squared. So square root of that is 15. All right, so we got those. All right, then since we're looking for this guy, which is the rate of change of x with respect to t, all right? So we just have to take the derivative of this equation with respect to time, right? So let's go ahead and take the derivative of the Pythagorean the equation here. And derivative of x squared would be 2x and multiply by dx over dt. Right? Derivative of 9 squared is 0 since it's a constant, and it's equal to, right? So you have derivative of r squared would be 2r times dr over dt, right? So we have that. Right, so both of these guys has 2, so I'm going to go ahead and cancel 2's, right? Then divide through by x to isolate dx over dt. So divide through by x, so dx over dt is equal to r over x dr over dt, right? luckily we know everything about these guys. R is 15, so I put that up here. All right, so 15 is right here. Right, we got R. All right, X. We know X is 12 right there. So 12. All right, dr over dt would be -4 right there. So it's put -4. All right, so it's 4 and 12 cancel out, 3. Right, and the 3 and the 50 cancel out, so 5. So it's going to be -5, right? So therefore, boat is approaching at the speed of 5 feet per second, right? So that's the answer for problem number 1. Right, that's it. I hope that this was clear.